In this video, we're going to talk about vectors and how to draw them. First, let's remember the difference between a vector and a scalar. A vector is anything that has magnitude and direction, like position, displacement, velocity, and accelerations. Scalars are things that only have magnitude, like time, money, and mass. So I can be going 30 miles an hour east, or I can be going 30 miles an hour west. And the number and the angle or the direction, that makes sense. But for things like time, money, and mass, I can have 10 kilograms, but 10 kilograms south doesn't really mean anything about the mass. Now, to draw a vector, we simply draw an arrow. So go ahead and sketch a y versus x graph and draw for yourself an arrow. That arrow is the vector. We can use this arrow to represent things like positions, velocities, accelerations, etc. And there is a very specific feature of this arrow that we're interested in. So the first is the length of the arrow. The length of the arrow is equal to the magnitude of the vector. And the direction that the arrow points, that's the arrowhead, so the direction that the arrowhead points lets us know about the direction. So we normally will use theta to represent that angle. So we'll say length equals magnitude, and theta is the direction. Let's talk about the variable that we use to represent the length of this vector. Typically, what we do is we say that this vector is some letter, so we'll say vector A, and we put the name of the vector near the head of the vector. And to represent the fact that A is a vector elsewhere, we will write a little arrow above the letter, telling us that A is a vector. If we want to talk about just the magnitude of this vector A, meaning only the length of this line, then what we'll do is either put absolute value bars around A with an arrow, or we use the letter without an arrow above it at all. So either of those things is an appropriate way for us to talk about the length of the vector. So let's get rid of this length, and we'll write either absolute value bars around the vector A, or A without an arrow above it. Okay, so that's how we can talk about the magnitude or the length of the vector. Now, vectors have these things that we call their components. Actually, before we talk about those, this would be a good time to talk about how we can name the vector if we are writing about it. If we wanted to talk about the vector A and what it is equal to, we would include both the magnitude and direction. So what we do is, in parentheses, we write A, the length of the vector, comma, theta, the angle. So that is one way that we could say what the vector is. So components, the components of the vector they're different. They're kind of like the x and the y coordinates of this vector. So if I was to think about the coordinate that I get here and here, I would get an idea of the x, comma, y coordinates of the object. But for vectors, what we say is that the vectors have components. And really there's going to be a vertical component, so a part of the arrow that points up. We would call this a sub y. And then a horizontal component that points right, because the arrow is pointing up and to the right. This horizontal component we would call a sub x. Now I'm going to erase this and just call the length of the vector A, so it's a little bit easier to see. So this vector has a magnitude of A, and then it will have an AY component and an AX component. The way that we talk about this vector if we use these components is we would write A equals AX, comma, AY. Okay, so either we can talk about the magnitude and direction, so or A and theta, or we can talk about the x and the y components, which are basically like the x and the y coordinates. What's nice about the x and the y coordinates is I can always think of them as making a right triangle. So like if I move this y coordinate over here, then I get a right triangle. And now I have a right triangle where the hypotenuse is represented by the magnitude a. The x component, or adjacent component, because it's touching the angle, is ax. And the y component, or the opposite, is ay. Now I can treat the vector like it's a right triangle and use the Pythagorean theorem and SOHCAHTOA to know all of the different parts about it. Like, for example, if I wanted to find the magnitude, and I knew the components ax and ay, then I would do the Pythagorean theorem, where you would get ax squared plus ay squared equals a squared. Or what I would do is just kind of take the square root and say that that is what the magnitude is equal to. In fact, I'm going to rewrite that. The magnitude is equal to the square root of ax squared plus ay squared. Okay, great. And let's say I wanted to find this angle theta. Well, ay is the opposite leg of this right triangle. Ax is the adjacent. And I could say tangent theta equals opposite over adjacent, or ay over ax. And to find theta, I would use the inverse tangent of ay over ax. So these are the equations that you're going to need to be able to work with vectors. Let's do some example problems. Find the magnitude and direction of vectors a, b, and c. Okay, so let's remember magnitude is the x component squared, square root of the x component squared, plus the y component squared, and the direction is going to be tangent inverse of the y over the x. Okay, so for a, I know that there is an x component of 3 and a y component of also 3. So if I want to find the magnitude of a, I would do the square root of 3 squared plus 3 squared, which gives me 4.24. Okay, then if I wanted to find the angle here, I'm going to call this theta A, since there's an A, B, and a C. And I would say theta A is equal to tangent inverse 3 over 3. And that gives me, well, hopefully you see it, 45 degrees. And remember to use tangent inverse on your calculator. You would press second and then tan, then enter 3 divided by 3. So that's how you get tangent inverse. Sometimes it's written as arctan. You might be familiar with that. Okay, good. Also, since we're working in degrees, your calculator has to be in degree mode. Remember that you can check by clicking this button right here, mode, and then going down to the radian degree setting. If you want to be in radian mode, you click radian. If you want to be in degree mode, you click degree. We're going to do all these in degree mode. Okay, so now let's do B. B has a x component, an x component of negative 3, and a y component of positive 2. So when we find the magnitude of b, we would do the square root of negative 3 squared, which becomes positive, plus 2 squared. This is going to give us 3.6. And the angle, which we'll call theta b, now this one's going to be kind of weird. We could do one of two things. One is we could literally just find out what this angle is inside of this right triangle that we've drawn. The other is that we can just use tangent inverse to find it. But when we use tangent inverse, So of 2 over, I'm sorry. Yeah, that's right, 2 over negative 3. Okay, so when we use tangent inverse to find this, second tan 2 divided by negative 3, most calculators are going to give you kind of a weird angle. So let's see what angle this gives me. All right, negative 33.69. We'll say negative 33.7. So this is a unit circle angle. It's in reference to the positive x-axis. The negative means that instead of going counterclockwise, or up above the axis, you go down, so clockwise. But the thing about these quadrants and angles, so here's the first quadrant, the second, the third, the fourth. The thing about this is tangent inverse can only give you angles in the first and the fourth quadrant for most calculators, because it doesn't know when you put this inside of tangent inverse, it doesn't know if this is a positive or a negative number, positive or negative 2, positive or negative 3. So it only gives you angles in the first and the fourth quadrant. So if you're in the second or the third, then what you have to do is add 180 to your angle. So 146.3. Let's write that down. 146.3. This angle is actually the angle of B measured from the positive x-axis. You're just using the unit circle angle. Now for C, you have a component of positive 2 and a y component of 1, 2, 3, 4. So negative 4. So when you get the magnitude, you would do 2 squared plus negative 4 squared, which gives you 4.47. But a similar thing happens when you try and find the angle, which we'll call theta c. I'm going to erase these components here. When you use the positive 2 and negative 4, like so, the negative 4 is y, goes on top, positive 2 on bottom. You're going to get negative 63.4. And you just have to think, is this a correct unit circle angle? If you're in the first or the fourth quadrant, then yes, that's a correct unit circle angle. And this is, in fact, negative 63. So negative 63.4 degrees. That does accurately describe this angle right here. It's negative because it's going below the x-axis when it counts it. Now, if I was going to write the coordinates of these vectors, or if I was going to name them, what I might do is say A equals its magnitude, so 4.24, comma, 45 degrees for the angle. B equals the magnitude of 3.6 times 146.3 degrees. And C equals 4.47, comma, negative 63.4 degrees. So these are all ways to say that you've found the vector A, B, and C. If you don't know, when you use like a magnitude and an angle, this is what's called a polar coordinate. But if you don't know that, that's totally fine. This is how we write out what a vector is using its magnitude and direction. So if I was asked to draw a vector and I was given this same notation, then what I would do is I would just go ahead and make a little y-x chart, and then realize that the 2 and the negative 6, those are the x and y components, which are like the x and y coordinates of my vector. So x comes first, 1, 2. Then I would go down 6, 1, 2, 3, 4, 5, 6. And my vector would start with its tail at the origin and its head would point right there. To find the magnitude, I would do the square root of 2 squared plus negative 6 squared, which is going to give me 6.3. We'll say 6.32. And then to find the angle theta, I would do tangent inverse of the y, which is negative 6, over the x, 2. And that would give me negative 71.565, so negative 71.57, negative 71.57 degrees. And because this vector is in the fourth quadrant, remember 1, 2, 3, 4, then that is the correct angle. It's just going to be below the x-axis instead of above it. Okay, great. This video was a little long, but you did a really good job using the components of a vector to find its magnitude and direction. This video is done.